Thanks for joining us today. Please feel free to file on in as you join us. Delighted to be moderating a panel of absolute superstars here to talk about one of my personal obsessions, what I think is one of the most interesting fields within our industry right now, which is this very rapidly evolving way that commercial industry and governments are starting to collaborate now in the field of sustainable Mars exploration. I feel like this field has gotten about 10 times more interesting just in the 6 months or so since we wrote the panel description for this and when we're talking to you today. So really delighted to have the chance to, for me to be quiet and for you to hear from our wonderful panelists. When we had our preparation meeting a few weeks ago, I was delighted by how quickly everyone agreed to no slides and very brief intros so that we could have the longest possible time for our discussion. So I will start with our introductions. Again, for each of these folks, if I read their full bios, that would consume our full hour. So pardon me for keeping it brief and really focused on current roles without too much about the past. So let's see, I'll start at my immediate right with Nick Cummings. Nick is the Senior Director of Program Development at SpaceX. He came to that role via other roles at the Kennedy Space Center on a technical capacity and on the Space and Science Subcommittee of the Senate Commerce Committee as well. Next in, we have Richard French. Richard is the Vice President of Business Development and Strategy at RocketLab, a role he came to after a wonderful career at the Jet Propulsion Laboratory. Dr. Nikki Fox. Nikki is the Associate Administrator for the Science Mission Director at NASA headquarters. Previously to that, she has a wonderful career in heliophysics as the Director of the Heliophysics Division and the Project Scientist for the Parker Solar Probe, one of the most awesome missions, certainly of my lifetime and in my memory. And then Amit Kshatriya, the Deputy Associate Administrator for the Moon to Mars program within ESD-MD, Exploration Systems Development Mission Directorate. I'm still working on that particular acronym. As the husband of a NASA flight director, I'll also point out among his many other accomplishments, he was Prometheus Flight as a flight director on the International Space Station. Thank you all so much for joining me today. Again, I'm fascinated that we've got this great mix of industry and government in a few different capacities here. Looking forward to a great conversation. I'll dive right in. We've seen a lot of great conversation over the last 6 months where there seems to be a growing interest in industry, in NASA, at the White House, and in Congress in borrowing the CLPS model, the Commercial Lunar Payload Services model, and in taking that to Mars. I haven't yet figured out if it's supposed to be CAMPS or COMPS or campus, but having that Commercial Mars Payload Services program built on that same model. I'd love for any of y'all to feel free to comment on, are we ready for that? Are we laying the groundwork for a program that's still a few years away, or is that something that NASA and industry feel ready to get going as soon as the funds and other legal implements are there? And what lessons can we draw from the program whose footsteps we're following in the CLPS program?
Who you want to start?
Sure, you spoke first. You want to
I wasn't meaning to volunteer. Okay, yeah, I'll start. CLPS was a program that was, in a way, structured, taking lessons learned from other programs like Commercial Crew, COTS, the progression from COTS to CRS, CCDev, to Commercial Crew. And with CLPS, what they did, which I think was kind of interesting, is they kind of cut out the progression and instead just went straight to, we're going to do, firm fixed price. We're big fans of firm fixed price, competitively awarded contracts. But they just said, we're just going to go straight to that, right? And I think that when NASA thinks about, I don't know, CMIPs, like whatever, CMIPs, okay. I think when NASA thinks about CMIPs, they might go back and look at CLPS and say, hey, was that experiment, did that get the capability that the agency really wanted? Should there have been a little bit more of a crawl, walk, run phase? Certainly one of the really important lessons from COTS was the fact that NASA wasn't, Kistler. If Kistler hadn't been terminated early in COTS, you would have never had Cygnus and, that very, very important capability that we still, use now. So, and that was kind of enabled because NASA wasn't, they kind of did that crawl, walk, run kind of approach milestones allowed people to kind of progress, have commercial milestones where they're needing to raise money or do other kinds of things that shows that they are progressing as a business while they're also progressing their technology. So I'd encourage NASA, go take a look at some of those things and see, go take a look at clips and kind of the outcomes that you've got there and see if some of those lessons might be applicable in the Mars version of it. But I'm sure industry wants it. I haven't heard anybody who said, no, we shouldn't do that at all. So.
I mean, maybe I can round out the industry perspective, but I certainly think that there are a lot of CLIPS lessons that we should observe and continue with. Firm fixed price competition key, but regular opportunities, predictable opportunities that companies can plan for, I think is also very important. I think that's a general problem across, space, science, and exploration right now is well, when is the next opportunity? Like, how do I put enough effort into civil space if the next solicitation's 2 years away? So lots of opportunity is important. I think it's also, it's kind of not talked about very often, but the service concept of CLIPS integrates the satellite mission with the launch. And so to have effectively what in SMD is called PI provision launch services as part of the approach, I think is very important. And I don't know of a single CLIPS team that's had a launch vehicle issue. I think it's, hey, they're solving hard problems, but I don't know of any, maybe there are stories of...
You're welcome.
Yeah, I mean, and I think it speaks to the quality of the commercial launch services that are available. But yeah, there are other lessons to learn. I mean, it's clear that the success rate, maybe suggests some lessons. And I guess I just want to, because I have been a little bit of a critic of CMIPs. How much are we emphasizing the commercial part? If the COTS in the CRS program and the people that developed it understood that commercial launch services was a healthy, thoroughgoing commercial concern. What is the commercial opportunity at Mars? So I think we just have to have an objective answer to those questions.
I'll just add, one of the interesting, to your point about the regularity, one of the interesting things about doing a program like that at Mars is that it has a built-in timing function, right? So, when the opportunities are, right? It's based on physics, right? So it's, every, roughly 2 years. And so I think that's an interesting thing to kind of factor into how you would structure a program like that is like, how do you take advantage of every single Mars window to accumulate, capability, but also make sure you have the industrial capability that's going to survive from window to window, and they're because they're doing other things.
Yeah, that was actually going to be my point.
Sorry.
No. Was that with CLIPS, there are landing windows, so that there are some constraints, but they're really not. Then it's not 26 months, and so I think that by that token, CMIPS will be a little different. I also think it's going to take longer to get something to actually land from a company who's never built a lander before. We know how hard it is to land on Mars. We've had successes, we've had failures. It is extremely hard. It's hard to land on the moon. It is really hard to land on Mars.
It's hard to land on Earth.
But the thing is, it's not just about the landers. I mean, this is about people think CLIPS and they think the L is the lander. Of course it isn't, it's the lunar. And so there is a lot to be done in orbit around Mars. It's pretty hard to go into orbit around Mars. These things are not easy. So I think it's actually going to fall well in the cadence of a 26-month, and hopefully we would have a couple of things launching in the window to arrive there. But there's a lot of work to do on exactly what we want to send to Mars. I don't see personally a huge commercial interest, at least in the near future, of going to Mars unless you're supporting NASA or ESA, or pick your favorite country, unless you're supporting their assets or their science, because we don't know what's in the regolith. We don't know all these things. We actually need to, before we send humans, we actually have to know if you can survive. What are the trace elements in the regolith? Are they going to kill you? How sharp is the regolith that's going to rip your spacesuit? There's these things that we actually need to learn about before we send people. And so I think there's a really great program of the kind of the know before you go kind of idea that we can do, and we can do it well. But I love CLIPS. I'm a huge fan of the CLIPS program. We talked about it in the earlier session today. But I'd love to see the same kind of, enabling companies to go forward and do these things, taking our payloads and doing really impactful science.
Yeah, I think the model's great. I mean, we're now starting to get engineering learnings from the CLIPS attempts, which is fantastic. To me, I think the first question you asked, or the question you asked was, are we ready? Yeah, oh yeah, because we need to start now.
Yeah.
To start banging away at the Martian surface as soon as we can, to start getting as much data as we can, whether there's a market or not. I think we can kind of meander on that subject. But I'm excited right now on any mechanism that allows us to stimulate private capital to come in to start helping us get those learnings as fast as we can. Because the serial approach to exploration, where we're kind of just focused on aggregation points, is a logical way to do it. But also parallel approaches are fantastic. Anything we can learn early is in our interest, even for the lunar campaigns. But I would say certainly for human Mars campaigns, we need it.
I'm delighted to hear all that. As someone who spends my day job, I run the team that co-developed the Ingenuity Mars helicopter. So I spend all my time thinking about exploring the Martian surface and having some predictability of when there might be rides that are going to Mars, to the surface, or maybe even in the general neighborhood is incredibly important for us to be able to think about what might come next and develop some of these other markets here. So I'm really excited by this conversation, and thank you for that answer. I feel like when I started my job not that many years ago, the intersection of commercial and Mars was approximately a null set. There wasn't a whole lot of even discussion about future Mars opportunities apart from the most aspirational science fiction inspired things. Whereas now, I think just in the last 12 months or so, we've seen NASA partnering with industry to study ways to enhance and improve the Mars Sample Return Program. We've seen the Exploring Mars Together project through NASA's MEP Mars Exploration Program that was looking at payload delivery services, was looking at comms relays, imaging relays. I don't want to ask you all to get too specific about the findings of those specific studies, although you're free to if you'd like. But I'd love to just hear, maybe starting from our NASA colleagues, what did you learn from those commercial studies? Did it teach you anything about when and how to bring industry in to be thinking about even the biggest of programs?
Yeah, I think it did. We certainly saw some novel approaches. We also saw, our NASA teams and our JPL teams come up with some really novel approaches as well when we, put the challenge to everybody. So I think they did a really good job too. I think a lot of it is competition is key. The sort of the idea of how we kind of partner with industry, partner with commercial to just make it a stronger mission. And some of the things that can be done don't need to be done by NASA. This is the sort of we talked about this morning, about, keeping the NASA-ness in what we do, which is we want to be focused on the cutting edge measurements, the new technology, pushing the boundaries, to quote Amit from yesterday, expanding the sphere of exploration and bringing everybody into the circle, so I think that really allows us to do that. I'm excited. I can't believe I'm going to pay Richard a compliment, but I'll have to do it. But I'm excited that we're going to launch Escapade this year, and that is, really the first commercial spacecraft going to Mars, and that's really exciting to be doing that, and to just sort of the same as we've done with most of the other missions at NASA, that we are partnering with industry on major components of those missions. And so it's really great to see a commercial buses going out to Mars, of course, going out with Blue Origin on their new land. So that's another exciting partnership for us. We've partnered obviously in the launch services. We've partnered with industry for years and years and years. And so I think that infusing and partnering is really the way to move forward together.
One thing I think I agree. There's been a lot more energy especially since the president, made the proclamation, even from his inauguration, that was going to be a priority, which is, filled a lot of us with kind of a lot of hope that was going to be a positive development. But we have been working on Mars activities in the human spaceflight program for a long time. A space station in particular. For the last 10 years, we have been using the platform to get reliability and engineering learning from the performance of the spacecraft. The life support systems are probably the most pronounced example, but we have spent time, and fortunately was able to contribute to this, in previous life, but spent time line augmenting the ISS life support system in a way for a 3-year transit. So 3-year reliability targets, 3 years end-to-end kind of missions to make sure that we have that retired before we start working on the harder problems that these guys are going to work on, right? So I mean, and right now we're reclaiming 98% of the water on ISS because of that data, and that took a long time. And having that in situ flight test, the kinds of things we learned when we did, the most ridiculous things that you would think that you would never learn if you tried it on the ground. One example is the carbon dioxide removal system. I mean, at the end of the day, we were when we first fielded the system, it's a pretty basic thing. I won't bore you guys too much, but you basically have a sorbent, it's in communication with the atmosphere, it absorbs CO2, then you put it in communication with vacuum and it desorbs, and you swing back and forth. And we're in the middle of the program as we're flying, we had the valves that were swinging the beds just fail over and over and over again. And we were just befuddled, couldn't figure out how to do it. And so finally what we realized, and again, you never would have learned this if you didn't fly it for years. The sorbent was dusting as the beds were being stroked. You're getting dust that was accumulating in places that our CFD wasn't predicting. It was seating itself on the ends of travel of the valves. And as it kind of caked around, the valves were the actuators were trying to chew through it, and they were shorting. That was it. That was what was causing this problem. The solution is easy. You oversize the actuator. You just have it was a 90-degree like windshield wiper valve. Instead, you just chew through it all. You just did a total ball. But I mean that, how do that learning doesn't exist. You can't find that. And so we have been doing it on the space station for a long time, and now, it's getting real. So that transit, so you look at ISS, you think in your head maybe that's what a transit vehicle might look like. At least certainly the real reliability, microgravity sensitive components of it that we know are going to be exposed. We're putting some of that risk behind us already, and now we just take the next steps.
One thing for sure, anytime you do anything new in space, you're going to find out there's yet another way that a valve can fail. Yep. It's like there's an infinite number of ways.
Spinning machines, anything that moves is going to fail on you.
A couple of people have talked about this like kind of dynamic of commercial and Mars, and is that like really a thing? And Nikki, I loved your point about launch services and the partnership that the launch services that like before there was COTS and CRS, there was the launch services at NASA when they kind of went out and started acquiring these commercial launch services when they were available. So I'm very proudly wearing my Psyche shirt today. There's no commercial business case in going to Psyche, right? But there's a very robust commercial launch market that enabled that mission, and that has saved, frankly, NASA quite a bit of money, in the last 15 years or so as the trend in kind of launch prices has come down, and so.
And reusing the boosters for Europa Clipper.
And then reusing the boosters for for my favorite NASA science mission of all time, which is Europa Clipper.
I'm sorry, you mean Parker Solar Probe?
I mean, sorry, I meant my favorite planetary science. So I think when we think about these kind of commercial partnerships at Mars, what we want to do is make sure that there are commercial applications it's not just commercial in kind of like name only. Maybe there's not an immediate market at Mars or a commercial opportunity that is at Mars, but there are absolutely ways to make sure that if NASA is the only customer for a system, you can still do firm fixed price, development, which you should do. You can still have competition, which you should do. But in order to really get like the outcomes that we have seen so far, we are currently building 2 starships a month, 2 starships and a booster a month at our Star Factory. 3 Starship launch pads in development. And this is for a vehicle that is like large enough that the fuel transfer tube is the size of a Falcon 9. Right, Falcon 9 booster, right? So this is the scale that we're doing that. And I think that kind of commercial application of what we're doing with Starship to launch Starlink, to launch satellites, to launch people one day, NASA wouldn't have that if you had just kind of specced out something and said, hey, go do this thing, you had to kind of give room for the commercial market to say, hey, maybe there's not a commercial market on the moon right now, but there is a commercial market for launch, right? And there is a commercial market for these other things, and then that's why we're willing to put in, more than half of the money, towards HLS, because we have all of these other things. And so I think you want to try to find those opportunities with Mars as well, and I think that they will be there.
I agree.
And maybe just to expand on that, we might think about it a little bit different at the kind of top level, because obviously the SpaceX mission is a little different than the RocketLab mission, and our we're a public company, SpaceX is private, and so I think there's some different kind of macro trends there. But I completely agree with the sentiment that when we think about addressing a really hard problem like Mars sample return or a Mars telecommunication orbiter, which on its face doesn't seem commercial at all, we think about our other businesses, and we're supplying components, we're building spacecraft, we're building launch vehicles, and what are the commonalities, and how does solving a hard problem here enable us to do business over here? And so that's in the commercial sector, that's the hard problem that we're trying to solve as we figure out how to have successful businesses. But these opportunities, I think, are really synergistic with it.
And it is hard. Like it's
not
hard
easy
to build these, and we need NASA as a partner to kind of, work with us and say, hey, I know we said we thought we were going to do this thing this way, but we had to kind of respond to where the market was actually going, and we had to do this different thing. And in the commercial market, we can do that very agilely, right? Sometimes that's hard with a NASA contract that said, oh no, the technical volume of your proposal said this, right?
But that's about the relationship. I think for a great example, Nick, during CRS, I remember specifically, that when we were after CRS-7, we were down for a little while. We were flying for almost every couple months, right, before CRS-7, and of course, kind of in a classic way. Well, we had the anomaly, we went and investigated, but we also continued to make changes, right? And we wanted to keep evolving the platform. I remember this because I was working on the other side, on the ops side, when this was happening. And to your point, there was the company's interest was to make sure we can land the boosters, because that was absolutely the case. And as part of that development, we had to kind of lighten up the vehicle, lighten up the Dragon, because you wanted to preserve performance. And so the way we worked that was together, right? And in order to lighten up the vehicle, we needed to change some of the rendezvous profiles, we needed to change some of the capture points and sequences, and we just did those things because they were safe. B, it still met the intent of the program, which is deliver the cargo. But C, it was a recognition that the company had its own interest, and we had to partner that. But there was transparency in terms of how that was going on. There was never any question. I mean, I would tell you there was, maybe some folks were wondering, why are we taking ballast? Why are we doing these other things? It's because, they want to reuse the rocket. That's a good thing. That's a good thing for the country that we have that, right? And it also fulfills the contractual baseline, right? But that partnership is essential to that kind of development.
I wouldn't want to miss an opportunity to pay Nikki a compliment as well, that, on a much smaller scale, on Escapade, we had the same thing. I mean, to get a mission to the launch pad is not a straight path. It's always a winding path. And to have, to be able to collaborate with SMD, as we manage a firm fixed price contract, as we learn, as we work with our partners and particularly at Blue, that's really valuable. So thank you.
Yeah. Thank you for building 2 Escapades.
So we talked a little bit about Escapade. Now, I don't have my slide rule in front of me, but I don't think we're going to be in one of those every 26-month launch windows when Escapade flies, which again tells me we're in this exciting moment where we get to kind of break the way we were thinking about it before and get extremely flexible about it. As those kind of capabilities come, whether it's through industry coming up with something that NASA didn't request, or NASA changing its requests, or us just sort of looking at the math in a different way, how nimbly can we start to fold that into long-range plans?
Actually, I think that the Escapade example is a really, really great one, because we were not able to launch at the time we really wanted to, and so we came up together, working really closely together, and with our friends at LSP as well, into how do we, what does a mission look like if you put it in storage in space, and then how do you do that in injection? So just because the 26, that's the ideal one, 26 direct injection, and obviously if you're sending humans, that's what you're going to do. You're not going to store them in space for a while. But we can take higher risk with our robotic explorers, and so that actually opens up more launch options. It doesn't open up more landing options because you're still going to wait for Mars to be in the right place. But it does open up maybe, if you miss that window, maybe you don't have to wait 26 months. Maybe we can use the lessons learned. I mean, it hasn't worked, we haven't actually tried it yet. It's still on the ground. But talk to me in a few months and we'll see how it's doing. But I think that was a really great opportunity for us, and we were really happy that Rocket Labs were willing to take the risk. It's risky. You're going to put us, you're going to store it in space instead of sending it straight to Mars. It's going to fly for longer than we had initially anticipated, but we worked very closely together on whether or not to accept that risk, and it was almost a no-brainer to accept it.
Yeah, and just so it's clear what we're talking about, so we're going to launch Escapade pretty soon, hopefully.
Pretty soon.
and so we're going to launch into a kind of high LEO. Our spacecraft will do the orbit raise and escape from Earth, and then we're going to go hang out at a Lagrange point, and we're going to wait for Mars to come around, and then we'll go. And so, yes, we're going to eat into the radiation margin of the vehicle. We're going to eat into the thermal margin of the vehicle. We're going to be in environments that we didn't originally design for. But one of the upsides is we get to do science at a Lagrange point. And so Rob Lillis is like, oh, I get a few more papers out of this. And so it wasn't all bad. It wasn't all risk. And yeah, we had the fuel to be able to do it. And so, yeah, I'm super excited about the mission.
I just love it when somebody says, we're just going to go hang out at the Lagrange point.
Yeah, it's easy.
As one does.
As one does.
Just go hang out there. I love it. So we've got Escapade on their way to Mars pretty soon.
Mm-hmm.
We've also had both of y'all's companies talking pretty vocally about other things that you have planned to go to Mars, whether it be Mars sample return, starships, right? I love that we're entering into a mode where I think the prevailing attitude in industry, at NASA, in all the corridors of power in Washington, D.C. is we should never let another Mars launch window pass and go unused, which I am incredibly excited about that. For SpaceX and for Rocket Lab, since you are launch providers, in addition to your in-space servicing and telecommunications and other business units, are we nearing a point where I can go on and just look at a manifest on a web page and sort of figure out when the next flights are departing to these systems? Is that here already? Is that coming in the relatively near future?
Start.
Sure. I don't think we're quite there, and a lot of those plans are close hold. I think, as everyone has said, these are hard missions, right? And so, particularly for a public company, we want to constantly manage expectations. And again, I think our businesses are slightly different in as much as I'm constrained by the public markets and quarterly earnings, and we have good access to capital, but not unlimited. And so I think we have a different set of constraints and value propositions that we need to meet. But yeah, we're really excited about some of the upcoming opportunities. We talked a lot about Escapade, but the Mars Telecommunication Orbiter Language and Reconciliation, which has been studied as part of the CMIPS program analysis, as well as long time studied by NASA as aging, infrastructure has aged, and as we approach human to Mars, increasingly obvious that we need communications capabilities, which was emphasized in the president's budget request. So really, when we looked at MSR. This is a program. I've spent 12 years at JPL. I left JPL thinking there's no way a private company can do MSR. And then we studied it for 2 years, and we concluded we could. Doesn't mean we can do it alone, right? There's all these specializations that we need to bring in, particularly when you're talking about bringing samples back and dealing with backwards contamination control and other really bespoke, capabilities. Have to do it as a team. But we have commercial capabilities in propulsion and deep space comms and nav and many other technologies that we can bring to bear and bend the cost curve. And so when we looked at it, the Mars telecommunications architecture kind of stood out to us as an opportunity. And so, that was a part of our architecture, and it's exciting to see that there may be an opportunity to compete to build that piece.
For our part, I would say yes, we're very close to that. I think that certainly our objective is like what you said. Don't let a Mars window go by. And Elon talked a little bit about this in his talk, where we want to use every window, maybe even as soon as the 2026 window, although, there's a, very aggressive path to get there. But, we want to use each one of these to learn more and eventually to start, building the infrastructure that we need for, humans to explore Mars and to do incredible science and to do, we don't, there's so many reasons that we want to go to Mars, but science is, there's just so much that we can do there. Some of the science we can do ahead of time, some of it we can do when we're there. So we do like to think of this idea of almost kind of like how we have transporter missions now, right? And everybody knows that there's going to be transporter missions, regularly. You can go on the website, we literally have a portal where you can go in and kind of book your ride. I would love to see the same thing for Mars, and I don't think it's that far. But it does come in those 2-year quanta, right? So, you are, somewhat limited on your kind of iteration speed because of that. So I don't think it's far off, and I think that, I think we're going to, I don't have anything to announce today in terms of a website to go to book your
Coupon code, maybe?
Yeah, coupon code, yeah. Everybody at Ascend gets 1 free payload to Mars, yeah.
Give $100 off.
Don't write that,
I
Jeff.
heard him say that, by the way. Yeah, I did. Yeah.
So I think we do want to do that. And then, on the communications side, we definitely see a need there. But you really need, we have a communications relay network now. Nikki has a communications relay network now. We definitely want to make sure that, those assets, we keep them as healthy as we possibly can, along with DSN and all of the other things. But we want to outgrow that, right? That's a great problem to have. We want to outgrow that. We have gotten very spoiled by being able to bring back, high definition video during Earth entry, which is, we're able to do through Starlink, because we just have this awesome, the way it works out, we can kind of communicate back up to Starlink without having to, go down through the plasma that usually causes the blackout there. So we've gotten spoiled by all these camera views that we get and all of this data that we get on Earth entry. And we're learning so much about, Earth entry and TPS technology and all the things from these missions. Well, we want to do the same thing at Mars too, right? And so we need a big pipe of data coming back. So I think the communications relay is going to be really important. But we also have to have something that we're relaying. There has to be activities happening that, kind of drive that back. So
Certainly, as we start sending more and more things to Mars, I know we want to eventually bring back rocks and people, but in the nearest term, we need to bring back data. I think several of you alluded to it in the president's budget request. In the One Big Beautiful Bill, they both included some discussion of Mars telecommunications orbiters. I won't ask our NASA guests to talk about any budget specifics, but can you just elaborate a little bit more on this comms budget, the link budget coming back? Are y'all viewing, is this a 5-alarm fire? We need crisis right now? Is this just prudent early planning for future needs? Is it somewhere in between?
I think it's prudent planning. To Nick's point, we do have the relay network that's there right now. It is getting old. It's they've been up there a long time, and so I really think getting ready to have the replacement for that is really important. I'm obviously as a scientist, I'm looking at what payloads can I put on, because let's face it, our Mars relay are all science. And that's why we go to do science. But that's why we explore, to do science. But I'm really excited about the idea of the sort of the manifest list. And in fact, what we will be doing in the president's budget request, it included a line for low-cost space, Mars instrumentation and missions, and we had an RFI that you mentioned before that went out to what are the interest, what kind of commercial partnerships are available. We've got all that we can. That's kind of our starting point. What instruments do we want to develop? What do we want to send plants out there and look at how they grow? What are the things that we want to do? How are we going to get weather models of Mars, because if you're going to send people, you need to know what the weather is. You need to know if there's a dust storm coming. There are all of these things, and so really, leveraging off the incredible work that our Earth Science division does in large-scale modeling, and how do we put that at Mars in preparation for people being there. And so things like this, regular cadence, a telecommunication network that's up there that could carry some of these instruments to actually be able to do that science and kind of infrastructure together is what I'm really excited about. And so we will start doing the work to be ready for when Nick gives me the Q code and I remind him that he said I got a free payload. There's no such thing as a free payload. But we will be doing that work to be kind of ready for what I would love to do is have, I used to call it like the pantry, where you'd go in and be like, oh, I can, here's my spice rack, I can put this on these little things, and here's a big instrument that can go on here. But the idea of just being ready to have instrumentation that somebody says, here's a plate, you put your instruments on, deliver the plate, and we go. So that's what I'm really excited about doing in the next couple of years to prepare for this regular cadence of going to Mars.
I think I'll speak more generally, because this is typically not something I haven't been thinking about this too much because of my normal job. But what I do think is exciting, and you heard it from these guys, and you kind of embedded in their thinking, and certainly from Nikki, because she thinks about the universe this way generally, and I just love to listen to it. But when we do expand our range of action, which is really what this is about, right? That's what really the vision is. It's in cis-lunar space, then out into the solar system. You start thinking about the entire solar system in the way we think about Earth, right? We start thinking about preferred areas and things that we care about, and we start thinking about, we recognize the space. We in our parlance now, Lagrange points and what that means, and these sort of balance points between all these different regions are, really a part of what space it's about. It's not just this void, right? We're starting to put some human notions about what they are, what they mean. And so, and I think part of that is just as we're allowed to expand our minds towards those destinations. And with respect to with comms in general, we've been spoiled, by just on Earth and then just in low Earth orbit by the capacity that was originally put in by the DoD and all the assets we've been given. So we tend to think about space activities typically in terms of the space segment. We've gotten better at thinking about the ground segment as part of as an integrated space activity, but the link segment is also going to be just as important. And so I think that now thinking about those three things together as we continue to allocate resources is really, that's important. We're going to need all of it, and the further we go, the more of that's going to have the robustness that we're used to on the surface here.
So we've been talking about missions and about capabilities. I want to turn to one of our audience questions here, and they sort of went to a different step on the ladder and looked at just basic technology development. They point out before you have CLIPS, you have Lunar Catalyst Program. A lot of these NASA commercial partnerships have had a stair-step kind of relationship to there. So is there an equivalent, is there a Mars Catalyst type program that we think would be beneficial that aims at specific technologies that might later go into a cruise stage or a landing stage or a surface vehicle?
Well, I think we've been, even as part of Artemis, have been fielding systems of, to try and anticipate that. I think I meant to put earlier about space station in terms of how we've been developing life support. Life support, as a spacecraft guy, that's the first thing that comes to mind is making sure that that's enabled. I do think we've made a ton of progress there. There are a lot of other areas that we've done gap analyses, and we understand kind of what propulsion technologies are required, and radiation and all the susceptibility and how that's going to deal with avionics. All of that is there. Particular areas we've written down. I think there's probably more gap analyses done than we have work being done to retire those gaps, maybe. But we need to start focusing and drilling down on those. But at the top of my head was always the human interaction with the spacecraft, and I think that in and of itself is extremely hard. But you guys have also the instrumentation and all sorts of other things that you need to get better.
Yeah, I can't say we've got a definite plan for the kind of catalyst thing, but we will be working very closely with our colleagues in STMD, the Space Technology Mission Directorate. We've done the sort of the tipping points. We've got the Catalyst Awards. We do a lot together. We've flown a number of payloads already on CLIPS that were from STMD because they wanted to do that tech demonstration of the tech maturation. So I envisage that will be very much moving forward, doing that gap analysis. What is the technology that we need to close that gap, and then adding that, so it isn't just about flying the same old things, but what is it that's really going to be that game-changing thing. So we'll work really closely with STMD on that.
Just Amit, has mentioned a bunch of times about how we've been able to use the space station for that, and this is a Mars panel, obviously, but there's going to be tremendous opportunities to use lunar exploration to advance a lot of those technologies too. The cycle time is faster. You don't have to wait 2 years until the next chance to try something different. So,
and we talk about all the time. I mean, what we're doing with HLS is burning a common target towards what the companies and the need for that. We have to retire that risk too, and so that's an elegant way we're just going to bite that thing off. We know we need on-orbit logistics. We know we need to be able to refuel and do things in space, and we know we're going to need that on the surface. We know that all that's going to be mandatory. So as much as we can bring that into the current programs of record and go start retiring the risk in a coincident way, then that's the biggest example, really, I think, right now. But it's everywhere.
Well, and Nick hit the comment specifically earlier when we were talking about some of the studies that have prepared the way for the CMIPS recommendation. One of the strongest feedback from industry engaging in that was consider how the technology needs to be advanced, certainly on the instrument and science side, certainly on the human exploration, human support side, but also on the platform side. And and the way I think about it is the further you get away from the commercial core. What is the most commercial thing we do? Direct to device, enabling, kids to text from Joshua Tree. I mean, that's probably the most commercial, and then you start getting further and further away from it. And
cat videos.
Cat videos, most commercial, application out there. And so when we think about Mars, the more you can help, the more successful it's going to be, and the faster we can go. And so thinking about what do you want now that we can do, like orbiter? Maybe the first thing you ask for isn't a lander. Maybe it is the orbiter or orbiters. I think about Phobos as an interesting, stepping stone. It's, the Japanese, of course, are going, and that's amazing. I'm happy to see that. It's kind of disappointing that NASA's not going to be the first to Phobos, right?
It's a partnership.
It's a partnership.
Yes,
Yeah.
NASA's partnering with Jackson.
Absolutely, yeah. We're on the mission. So I think that to go back to one of those specific recommendations that have come out of those studies is anything you can do to help prepare us to deliver better on those missions, the more successful they'll be.
So looking at future missions, Nikki talked about the missions we have sent already. Science has been the goal. I have a science background, so all excited about that. Obviously, humans seems to be an increasing priority of our presidential administration. In my mind, the science feeds into the human program, which feeds back into the science program, and has a nice. You can't send people if you don't know where they're going to land safely. And once they're there, they'll bring back lots of results. As we think about on-ramps for commercial to assist NASA and its goals, are those separate on-ramps for assisting science and for assisting human spaceflight? Do they need to be separate programs? Does one happen before the other, after the other? Or are those really blended together?
I think they're really blended together. We explore to do science. That's why we go. Even if you just land on the surface and look around and write down what you see, that's science. That's an experiment. You just did it. I think that it shouldn't be a separate program. As we're looking at the support for Moon to Mars, I don't think of it as this is my program here and this is Amit's program over there. We totally are blended in what we do, and we will fly things on clips that are directly for supporting Moon to Mars. We'll fly other things that are decadal level lunar science, and so that's just what we do. And CLIPS is such a great example because we have the tech demos, we have the commercial payloads, even we have the looking at the plume interaction, because that's really important for Moon to Mars. It's less important for science. It's interesting, but it's really important for what that plume's going to do to any equipment that might be by a lander. So I think it's just an extension of the incredibly close partnership that we already have.
I totally agree. Every time we expand our range of action, commerce occurs, and more importantly, at least for me, and what to me just gets me up every morning is every time we we send explorers to new places, we create more explorers because people see that and they believe that we birth scientists into the world. I mean, it's a totally virtuous cycle, and that's why this is so exciting for me. I think for all of us.
Countdown clock is saying we're almost done, which can't possibly be right. It feels like this has gone so quickly. Maybe I'll ask one final question, and then we'll thank our panelists here. So I mentioned, to me, when I started my job working Mars helicopters 2 years ago, commercial and Mars were never in the same sentence. Even within the 6 months in between when this panel was sort of dreamed up and added to the Ascend agenda, and today, I've seen a lot of progress. What would y'all most like to see in the next 12 months in between Ascend 25 and Ascend 26 that will make this even more of a reality, make Mars business a bigger market line for our commercial industries, make commercial industries a better partner and a more important partner for our friends at NASA?
So for us, the critical path to the moon and the critical path to Mars is the same critical path right now.
Exactly.
And it will be for like a little while. The propellant transfer, on-orbit propellant transfer, fully reusable super heavy lift launch. We've built the machine. People have seen kind of the flight tests, which are great. But what they don't see is the huge machine that we have built that is building the machine, and how much progress has gone into that. So, we have queued up an incredible amount of industrial capability for the moon, for Mars, for science missions, for commercial missions, and so for us, that kind of critical path is going to be right through version 3 of Starship. Should be ready by the end of the year. We have a couple of version 2s left that we're going to fly. And then we're going to, propellant transfer is the next big thing, while we're also perfecting reusability of the ship. We've already reused a super heavy booster, so there's some pretty big milestones coming in the next 12 months. And I personally am excited about the fact that, again, that critical path is it's not about trying to decide between the moon or Mars. It's like it's advancing it for both.
I think your question is like, what do you hope for in the next 12 months for the next Ascend? And I think what I hope for most is that we somehow can translate the sense of urgency that we all have, and whatever is motivating your sense of urgency, whether it's geopolitical competition, whether it's commerce, whether it's inspiration to go to Mars, and turn it into action, which creates opportunity. A company like RocketLab, which also has a lot of industrial capacity that we can apply to this, but is not necessarily as heavily engaged in the Human to Mars program, how do we get involved? And that has to be through new mechanisms, new opportunities. I think the current program is amazing. Like, I want to see us back on the moon. I want to see us on our way to Mars. But I think about the daunting list of challenges, and we've got to just all be hands on deck, or all hands on deck. And so hopefully next year at Ascend, we'll be talking about all those new opportunities that we've gotten engaged in.
Yeah, obviously, I'm looking forward to Escapade being in space by next Ascend. Probably not quite on its way yet. It'll probably still be hanging out, but having it in space is going to be really exciting. But what I'm really looking forward to is the knowing what the cadence is going to be, like what opportunities we're going to have, what they look like. Is it an orbiter? Is it a lander? Is it what are we carrying? So that we can actually start putting together the science program behind how we're going to take advantage of all this amazing things. When I look at Moon to Mars, and the CLIPS program, but really focusing on Moon to Mars, we had science experiments on Artemis 1 in the Orion capsule. We're working closely on what could we put on with Artemis 2. Artemis 3, we've already selected 3 experiments that the astronauts will take down to the surface and deploy. For Artemis 4, we're looking at handheld tools that the astronauts will have in addition to more science that's going to the surface. And so it's really about what it's enabling For us, obviously bringing back the samples is a huge thing from the moon for us. As I think about going to Mars, I mean, I'd love to see a real concept for bringing back not just any rocks, and I'm going to just wax lyrical about my 4-billion-year-old Nowakian megabrachia that have been carefully selected by Perseverance. And these samples don't exist anywhere else. So there are no 4-billion-year-old rocks on the Earth. And so these don't exist anywhere else, and they're in a very hard place to get to. And so, you know, a real plan that we could say, yeah, this is something we could go forward and actually do, and do it in an affordable way in partnership, I think is something that I would love to be at Ascend next year and say, this is the plan for a Mars sample return. That would be my perfect Ascend.
Yeah, I would say to your point, I think Richard is a great one. Let's talk about what the plan is, right? And what's the action? Hopefully when we come back and talk about this next year, humanity will have returned and has now direct experience of flying around the moon, because that's the plan, to get it done before we come back here. And then also, you know, if we could get propellant transfer done at scale, that unlocks everything, right? So if we can say those two things next year, which by the way, that's the plan, right, then we can talk about that. And now we really know, hey, this is the sense of urgency, the possibility, how that gets created. That's what I want to be talking about.
We had a little stoppage time added. So I want to end here with my new last question here. I feel like a common theme in a lot of this discussion here has been, how do we wring every drop of value out of every opportunity we have to do anything at Mars? Which again, I'm extremely excited about. I think about launch vehicles, I think about sample tubes, right? I am tempted to, just as a private citizen, start a GoFundMe to grab all the sample tubes for the Three Forks Depot as well, right? If we're going to bring back the 30, we've got the other ones. I want every one of them back, as I know everybody in the science community does. We're also in this interesting spot where, because we have so many new capabilities being developed, we've had companies start talking about, I'm going to fly several starships, maybe as soon as 2026 or 2028. We talked about missions going to Mars, missions going to Venus, maybe, that are privately ideated and initiated. Are we approaching a world where some of those vehicles might fly without being full? Are there on-ramps for us to go and fill those up? I will admit, I asked Grok to calculate how many Ingenuity helicopters fit inside a Starship, and it's something like 10,000.
Yes.
So how can I get my 10,000 Mars helicopters on board one of these vehicles? How can we make way for these sort of late-breaking opportunities to help researchers out in our audience, in the international community, our partner agencies, academics, maybe even my school kids, find ways to bring every drop of value out of those things that are heading in the right direction?
I mean, I think that's a great question, and we are very, SpaceX is very focused on the transportation, problem, as we have been, and to a degree, the communications, the kind of communications and transportation is kind of like what we do, right? But there's an enormous amount that provides an enormous amount of opportunity, but that also means that there's like a lot of other stuff that has to be built, right? And so that we can get it, to Mars. And I do worry a little bit if the things that we need to do exciting things on the surface of Mars or in Mars orbit, we have to think about that a lot differently than we've thought about it in the past. Starship is probably not going to be mass limited for delivering stuff to Mars. Like, it's unlikely we're gonna have like a payload complement, especially like early on, that maxes Starship out from a mass delivery capability. It might be volumetrically limited, but so we can start thinking like, how do we build things at scale for Mars? What is the equivalent of like what we've done on the launch side and are continuing to try to do to bring down the cost by orders of magnitude, per kilogram to space? What is on the other side of that, where we can lower the cost of building things for other planets by 1 or 2 orders of magnitude, right? So I think that's a really interesting problem, and I really hope that there are people here at the conference, who are thinking about that and are going to make that happen. So we're going to hopefully be able to provide that opportunity, but I think it's going to be up to the entire space community and international governments and partners and NASA to like really make that happen.
Yeah, I mean, let me take a little different angle there. Every piece of hardware that gets built for space is a really hard problem. And it takes so much advocacy and so many stakeholders to come together and decide to do it. And so if we're relying on transformative launch costs or, not building space systems efficiently like we do, or other hopes and dreams to execute on programs, we should think about that. Because it's not going to be cheap. Like, we're going to have to pay for it if this is worth doing. And yes, so we have to build a coalition of the willing, and yes, fund those programs. I mean, I think about HiRise has imaged, 5% of Mars? Like, it's amazing, actually, when you think about it. HiRise has been there for how long, and it's only covered 5% of Mars. That's really the key data set for landing safely right now, until we come up with something else. So we got to get another HiRise up there, or maybe a whole constellation of HiRises. Or maybe if you get 10,000 helicopters, we can image it that way. All of that costs money, and so I think that we have to be really objective about what the priorities are, and it's got to be a team effort, right? It can't just be one solution that we're relying on to solve the whole problem.
I think you kind of nailed it there, but it kills me to think that we would not use every drop of the capability. I mean, it's something that we've really embraced rideshare to lower the cost of launches, putting that excess capacity on. I mean, SpaceX is really good at actually adding things even after we've got our NASA payload on, and some of them take every single drop of the Falcon Heavy, and some of them don't. And often there's other things that are on the stack, and I think that that helps lower the cost for us. But just really, it really kills me that we might not, we might send something empty. I mean, I think I probably wake up at 3 o'clock in the morning crying about an empty thing going to Mars. So having the opportunity to put together the program, so again, I'm excited about this low-cost Mars line that we have, to actually be able to take advantage of that. I'm sure the first couple will not be full, to Nick's point, because there's a lot to be learned. You've still got to fly a vehicle for the first time to Mars. We even know that's not easy. Going into orbit, landing, whatever the challenge is.
A lot of risk.
There are a lot of risk, and there's a lot of things that need to be retired. And so, you're not going to put this incredibly expensive payload on the first one, because that's too risky. But I'm going to put something on that maybe just takes advantage of the journey, and then if it doesn't land, it doesn't land. But actually putting that thought into almost the tiers of how you're going to approach exploring Mars. There's a lot to do. Rovers have been down there for a long time. We've had many other rovers beforehand, and we've only mapped a very small path. When you actually look at how the traversal of Perseverance, in the great scheme of things, it's not that far. It's huge for what it's done on Mars, but it's not that far. There's a lot to do. Flying helicopters is great, but 10,000 in one place is not particularly helpful. So that's just a cloud. But thinking about how you might have a network, how do you drop off helicopters in different places? They're really exciting engineering problems. This is what I get really excited about. How do we do that kind of thing? How do you globally image Mars? How many kind of GPS-like orbits do you need to have to be able to do that really detailed mapping of Mars? And so they're the things that excite me. I'm okay with the fact that the first couple won't be full, but a couple of years in, there shouldn't be a drop left on those assets.
This is probably not how you're going to want to have ended this panel, Bill, but what I see, because of what I do normally and what I've talked to these guys all the time, what we need to enable, we talked about how enormous the expense is going to be to do these things, and what it's going to take to do it, and the alignment we're going to need from stakeholders and resources and private capital and governments, et cetera. It is going to be large. It's going to be large, but we haven't talked yet, and I think really this is important, about how to make sure that the things we're doing make them have to cost as little as they can. And so what I'm saying is acquisition reform. Okay, acquisition reform is also going to be very important to enable more companies to come in to do business with us, do business with them, to do different sourcing methods and all those other things to bring all those resources to bear. We need those things. Fortunately, we got, direction via executive order to start implementing reform to the FAR just in April. Not a lot of people talked about that, but that is huge for us, and it's going to be huge for other procurements across the government. And so yes, they're going to cost a lot, but we also have to make sure that things cost what they should cost and not what they cost today. Right, because of the way we procure and the way we specify and the way we, source and the way we do these things. So it might sound like it's divorced from, the aspiration of, deep space exploration from now till the end of time. But if we have acquisition reform, we're going to get there.
Hear, hear. Well, audience, I don't know about y'all. In 2025, I look for every reason I can find to be hopeful and optimistic. I feel more hopeful and optimistic knowing we have minds as curious and thoughtful as our 4 panelists on stage and the organizations they represent thinking about this stuff. Please join me in thanking all of our panelists.